Today we're looking at angles and parallel lines, and there's going to be a little algebra involved in this one. So as a quick review, two lines are parallel if and only if corresponding angles are congruent, alternate exterior angles are congruent, alternate interior angles are congruent, and the same side interior angles are supplementary. So all of those conditions have to be satisfied in order for those to be congruent. Parallel. Okay, so the special relationship between these angles formed by those two parallel lines in a transversal can be used to find some unknown values. So here we go. We're going to find the missing values in each of these figures here. So for the first one over here, I see I've got two parallel lines, and then I have two unknown values also. I've got an x and a y, but they gave me one of the angles. They told me this angle down here is 55 degrees. So the relationship between this angle and this one right next to it is they form a linear pair. Now, since they are a linear pair, that means that they are supplementary. So that means I can add them together and they would equal 180 degrees. So I'll do a little bit of work here. I'm going to say x plus 55 equals 180. And then I would solve that using the subtraction property of equality. So this would be x plus 55 minus 55 equals 180 minus 55. And so on the left, that gives me just x. And on the right, 180 minus 55 would be 125. So the value of x is 125. Now I'd like to note that it's not 125 degrees because if I look at the picture, it says x degrees, so the degree symbol is already there. So I'm only including the value for x. Now on my picture, the y value has a relationship with the x, the angle called x there. These two are between the two parallel lines, so they're going to be interior. And in relation to the transversal, they're on opposite sides. So these are going to be alternate interior angles. And the relationship between alternate interior angles on parallel lines is that they are congruent. So if x is 125, then y is also 125. Looking at the second one here. I have two parallel lines here, and so this line is my transversal. The two angles that they have labeled on here are outside of the parallel lines. So these are going to be exterior, and they're on opposite sides of the transversal that's given. So these are alternate exterior angles. And alternate exterior angles are also congruent. So if I want to find the value of x, I would set these equal to each other. So x minus 10 is equal to 104. And then I would solve this using the addition property of equality. So I'm going to add 10 to both sides. So on the left, that'll give me just x. On the right, 104 plus 10 would be 114. So on this one, x is 114. And I think I accidentally cut off the degree symbol there. There should have been a degree symbol on the outside here. Sorry about that. Okay, looking at our third example here, this one has both x and y in it again, so we're going to have to find both of those. The first thing I think I want to find is actually going to be the y, because I have a known relationship between these two angles here. So familiarizing ourselves with our picture, we have parallel lines. This one that is more vertical is our transversal. And so these two angles that are here are corresponding angles. And corresponding angles are congruent. So if this one is 114, then y would have to be 114. Now from there, I can use the fact that this is 114 to help me find x. The relationship between this angle over here, this 114 angle, and the one that involves the letter x is that they are supplementary. They form a linear pair. So in order to find the value of x, I'm going to have to set up a little equation. Supplementary, remember, means when you add the angles together, it equals 180 degrees. So I'm going to say x plus 12 plus y, which is 114, equals 180. And then we'll solve from there. So I'm going to start using the substitution property by adding these two constants together. So 12 plus 114 is 126. And then I would use the subtraction property of equality to get the x alone. So I'm going to subtract 126 from both sides of this equation. And so 180 minus 126 would be 54. So that means our x is 54. And once again, I'm not writing degrees on here because it's already included on the picture. All right, on our last one over here, the two angles that we have both have x's involved in them. So there is a relationship between those two angles. This one, first of all, is this angle up here, and this one is this angle down here. So we've got our parallel lines. The two angles that they have labeled are between the two parallel lines. So they are interior, and they're on opposite sides of the transversal. So they are alternate interior angles. And alternate interior angles are congruent on parallel lines. So that means to solve, I would set these equal to each other. Okay, now this time I'm going to use a couple of properties at once. I'm not going to write them out. I just wanted to review those properties with those others. So for this one, I'm going to subtract x from both sides, which would give me just x on the left. And I'm going to add 15 to both sides, which would give me 70 on the right. So for this one, x is 70. All right. So next up, we're going to find the measures of the angle in bold on this picture. So this is very similar to what we were doing before. They're just asking for the angle measure instead of the value of x. So for this one, our first step would actually be to find the value of x, and then we would have to resubstitute in order to find the angle that they're asking for. So to make sure that I don't forget that, I'm going to go ahead and write that down. I'm going to say 20x plus 5 is equal to, and then I'm going to write 20 times something plus 5 equals, and then whatever I get for that calculation after I found x, that's going to be my answer. So ready to go back and find x now. So now for x, I'm looking at the two angles that they give me. I've got two parallel lines. I can tell because they marked them. So this is our transversal. The two angles that they have marked are between the two parallel lines. So that means they are interior angles. And they are on the same side of a transversal. So these are same side interior angles. The relationship between same side interior angles is that they are supplementary. So that means they add to 180 degrees. So I'm going to add these two angles together. And that sum would be 180. Okay, so now I'm going to use substitution property to combine my like terms. I'm going to use substitution property actually twice here. So I'm going to combine my x's. That would give me 44x. And I'm going to combine my constants as well. So 5 plus negative 1 would be 4. And then to solve from there, I could use the addition property here, or I could use the division property. Everything here is divisible by 4, so I think it's actually easier to do that. If I divide 44x by 4, I get 11x. I divide 4 by 4, I get 1. And 180 divided by 4 is, let's see, 45. Okay, so from there, I would use the subtraction property, subtracting 1 from each side. It's going to move over a little bit because this took up too much room. And then I would use the division property of equality, divide both sides by 11, and I get x is 4. So now, remember that was just the first part of the problem. I still have to find the angle measured in bold, which I wrote down before to help me remember. So I'm going to put a 4 in the blank there, and then I'm going to perform this calculation. So 20 times 4 is 80, plus 5 would be 85. Okay, now on this one, in the picture, they did not have a degree symbol on the end of this, and I'm not just finding x, so I'm actually finding the measure of the angle. So I would need to put the degree symbol on this one. All right, hopefully you're getting really comfortable with these properties now. Okay, so next up, we're going to identify the relationship. So this time we have to state specifically what that relationship is between the two angles. And then we're going to find the value of x that would make the two lines M and N parallel. So that's what this notation here means, M parallel to N. So we're going to find x such that M is parallel to N. Okay, so looking at this picture, here's my M and my N. I'm trying to show that they are parallel. This is our transversal. So the two angles that are given here are between the two lines that we think are parallel. And so that would make them interior. And they're on the same side of the transversal. So that's going to be same side interior angles. Okay, the relationship between same side interior angles is that they are supplementary. So take a moment and pause the video and set up your equation here for this one. Okay, so hopefully you got that set up correctly. Now that you've got it set up, you'll use the substitution property to combine like terms over here. So that would give us 4x plus 8 equals 180. And again, we could use the division property to divide out a 4 from everything. So this would be x plus 2 equals 45 again. 180 divided by 4 is 45. And then subtract 2 from both sides. So we would get x is 43. So for this first one here, I've got x is 43. Okay, on my second example over here, take a moment, pause the video maybe, and think about it. And think about the relationship between those two angles. So hopefully you came up with alternate exterior angles. These are our two lines that we're trying to prove are parallel. So this is the transversal that relates these two angles. They are outside the parallel lines, so they're exterior, and they're on opposite sides of the transversal, so alternate exterior. So that means those two angles are congruent. So again, you can pause and set up your equation, and then come back and see how you did. Okay, so since they are congruent, that means the measures of the angles are equal to one another. So I'm going to solve this one using a little bit quicker algebra there. I'm going to subtract 2x from both sides and add 144 to both sides. And then I'll divide both sides by 4. So 144 divided by 4 would be 36. So on this one, x is 36 to make those two lines parallel. Couple more quick examples. If you're feeling pretty good about this, you could pause the video here and then try to work both of these out, and then see how you did. Come back and check yourself. Okay, so on the first one here, we've got these two lines that we're trying to prove are parallel. So this line is the transversal that relates these two angles, and this is maybe just a tiny bit ambiguous, but the 11x minus 2 belongs to this angle over here. It's a little bit closer to that vertex than it is to the other one there. So these two angles are corresponding. That's the relationship. Okay, so in order for the two lines, the V and the U lines to be, oops, this says M and N, should have been V and U. All right, in order for V and U to be parallel, then these two angles would have to be congruent. So that means I would set those up equal to one another. Let's say 11x minus 2 equals 130. And then I would solve for there. So I'm going to use the addition property of equality. That would make that 132. And then the division property of equality. So I'm dividing by 11. 132 divided by 11 is 12. So x would have to be 12 on here. And again, that was supposed to be V and U. Okay, next up, we've got this other lovely diagram here. We've got L, M, and N. And at a glance, I would say that it looks like those three lines are parallel, but I don't have any markings to prove that. So line T here would be my transversal, and my job is to prove that these lines are parallel or find the x value that would make them parallel and the y value on this one. Alrighty, so looking at my picture, I think I'm going to focus on the x's first. So for my x's, I've got this angle and this angle are both marked with x's. So I think I'm going to look for a relationship between those two since it only has one variable involved in it. One variable is something that I could solve for. If I had more than one variable, then I would have bigger problems here. Okay, so these two angles are between the parallel lines, so they would be interior. In relation to the transversal, they're on opposite sides of the transversal, so these would be alternate interior angles. All right, now, in order to find the value then of x, I would have to know what the relationship is between alternate interior angles. And that relationship is that they are congruent. So I would set 12x minus 46 equal to 9x plus 8. And this would be a good place to pause and you do that, and then solve and find the value of x. I got that x is 18. And for this one, we were actually proving that L and N were congruent. I apologize, I missed that when I was putting this together. All right, so now for the y, we're looking at the relationship between the y angles here. These two angles are they are between the two parallel lines, so they are interior. And in relation to the transversal, they are on the same side of the transversal. So these would be same side interior angles. And so the relationship between same side interior angles is that they are supplementary. So to solve for y, I would have to add these two angles together and set it equal to 180, and then solve for y. So you're going to pause now and do that. And you should get y equals 16.